Welcome, stargazers. If you put your faith in it and imagine a heavenly event so large that it obscures areas on Earth, you may witness something truly remarkable. Imagine a cosmic spectacle hidden just beyond our reach, at the very edge of visibility in Orion. Betelgeuse, a star in the Orion constellation, has been acting strangely, possibly signaling an impending explosion in the cosmos. If Betelgeuse explodes, our sky will shine brighter than ever. But when will this happen? According to researchers, it appears that this celestial event holds secrets waiting to be uncovered. Join us as we delve deeply into the specifics of Betelgeuse and its potential effects on Earth and beyond. A nearby planetarium has discovered that Orion is approximately 650 light-years away from Earth. The star Betelgeuse is no ordinary star. It is a red supergiant, one of the brightest stars known to us, shining brilliantly and more than 100,000 times larger than our Sun. But why is this red giant so significant? Betelgeuse stands out not only because of its brilliance but also because of its historical and cultural significance. The name originates from the Arabic word Yad al-Jawza, meaning the hand of Orion. Betelgeuse has been observed and documented by ancient civilizations for centuries, serving as a guide for travelers and a source of wonder for astronomers. Its deep red color sets it apart from other stars. Can you name the stars in the Orion constellation? Imagine a single star so massive that if it replaced our Sun, its outer edges would extend as far as Jupiter. Despite its enormous size, Betelgeuse is only about 10 million years old, significantly younger than our 5-billion-year-old Sunday. However, its immense mass causes it to burn through its fuel much faster, leading to a much shorter lifespan. This celestial behemoth, large enough to contain more than 1 billion suns, is approaching its final stage. When massive stars like Betelgeuse reach the end of their life cycle, they don't simply fade away. Instead, they go out in a dramatic cosmic explosion, an extravagant supernova that releases an unimaginable amount of energy. Such an explosion can briefly outshine an entire galaxy, creating shockwaves that span vast distances. The last time Earth witnessed a supernova this close was in 1604, before the invention of modern telescopes. The most recent supernova visible to the naked eye in the Milky Way was the Kepler supernova, which remained visible for over half a year. It was so bright that it could even be seen during the day for several weeks. What do these celestial events reveal to us? Ancient records from civilizations such as the Chinese and Europeans describe the appearance of these new stars. Interestingly, remnants of past supernovae can still be seen today as expanding clouds of debris, providing insights into the violent ends of massive stars. Supernovae visible from Earth are rare, but imagine a stellar explosion so intense that it rivals the brightness of the full moon. It could cast shadows on Earth at night and be visible even during the day. The radiation from such an event could impact satellite operations and even influence Earth's climate. Betelgeuse's unpredictable dimming patterns suggest it may be preparing for such a grand event. Could we be on the verge of witnessing one of the most dramatic cosmic explosions in history? Between October 2019 and 2023, astronomers observed an extraordinary transformation in Betelgeuse, known as the Great Dimming. The star, which had remained relatively stable for centuries, suddenly began to fade noticeably, so much so that even casual stargazers could see the difference. This led some to speculate that a supernova might be imminent. By April 2023, observations showed that Betelgeuse had returned to its normal brightness, leading many to believe that the anomaly had passed. However, in the months that followed, the star's brightness surged by an astonishing 50%, an unexpected behavior for a star with previously predictable luminosity cycles. This sudden fluctuation sparked discussions among astronomers. What caused this dramatic change? Why did one of the most well-known stars in our night sky suddenly behave so unpredictably? Stars are not static. They are dynamic celestial entities with their own life cycles and mysteries. While periodic brightness variations are common in some stars, Betelgeuse had long followed a stable 400-day cycle, until the Great Dimming disrupted it. One compelling hypothesis suggests that Betelgeuse experienced a massive surface ejection. Recent data from the Hubble Space Telescope revealed that Betelgeuse had expelled an enormous amount of material into space, 400 billion times the mass typically released in similar solar events. This ejection was several times the mass of our Moon. Such events can create thick dust clouds around a star, temporarily blocking its light and causing an apparent dimming. As the dust disperses or is pushed away by stellar radiation, the star's brightness returns to normal. This may explain the sudden fluctuations we observed in Betelgeuse. These new developments suggest that Betelgeuse is far from done surprising us. It may be approaching the final phase of its life, a supernova explosion that could briefly outshine the entire galaxy. A supernova occurs when a star's core undergoes a sudden transformation. In some cases, this happens when a star absorbs too much matter from a neighboring star. In Betelgeuse's case, it would be the result of exhausting its nuclear fuel. When this happens, the core collapses under its own gravity, triggering a catastrophic explosion. Massive stars like Betelgeuse begin their lives by burning hydrogen in their cores, a process that can last billions of years. However, as they run out of hydrogen, they expand into red supergiants, entering the final stages of their evolution. Could we be witnessing the last moments of Betelgeuse? If it explodes within our lifetime, it will be one of the most spectacular cosmic events ever seen by humanity. Keep watching the skies. History may be written in the star. Sources for Betelgeuse are as follows. As the hydrogen runs out, it starts to burn helium, resulting in the formation of oxygen and carbon. During this transition from the main sequence stage to the helium burning phase, the star undergoes significant changes. Over time, it transforms into a red giant. As the star's helium reserves decrease, it undergoes additional changes and expands into further stages of burning, each marked by the fusion of increasingly heavier elements. The larger the star, the faster these transitions occur, given the immense forces of gravity at work. The culmination occurs when iron begins to form in the core. In contrast to lighter elements, iron does not release energy when it fuses. The resulting energy is inadequate to counter the star's own crushing gravity. The star grows larger in size before eventually collapsing, causing a significant rebound explosion, resulting in a powerful supernova. So, is Betelgeuse nearing a catastrophic end, or is it simply biding its time? Ongoing research by Tohoku University in Japan suggests that the star might currently be in its carbon-burning stage. A scientist, Hawk, believes that the internal structure could collapse once its carbon reserves are exhausted. However, not all researchers agree. Studies from the Konkoly Observatory in Hungary consider the possibility that Betelgeuse is still in its initial stage of helium burning. One thing all scientists seem to agree on is that Betelgeuse is expected to follow the Milky Way's supernova cycle. However, determining the timing of this event remains a vast guessing game, with estimates ranging from a few years to 100,000 years. Amid these scientific speculations and discussions, one thing about Betelgeuse remains unchallenged: the nature of our observations. When we look up at the starry sky, there is a subtle paradox that we often overlook. This paradox lies in our understanding of time and light. The vast universe contains stars and celestial bodies so far away that their light takes an immense amount of time to reach our eyes. Even at the impressive speed of light, 186,282 miles per second, there is still a delay. For Betelgeuse, this delay means we are witnessing a light show from 650 years ago. To put that into perspective, when this light finished traveling to Earth, the Renaissance was just beginning, and explorers like Marco Polo were making history. Every observation we make of Betelgeuse is like looking through a vast time capsule, giving us glimpses into its distant past. If Betelgeuse had already exploded in a brilliant supernova, we would not see it for another 650 years. While we investigate and forecast its approaching supernova, somewhere far away in the universe, this incredible event may have already taken place. We are just waiting for its light to reach us. This N 2023 X connection. The controversy over Betelgeuse has sparked intense discussions within the astronomy community. Recently, astronomers observed SN 2023X, a supernova in a galaxy neighboring the Milky Way. This discovery reminded many of the fascinating and mysterious dynamics of the universe. Millions of people witnessed the 2023 X from a distance of light years away, watching as its brilliance instantly outshone its host galaxy. What intrigued researchers and casual observers alike was its uncanny resemblance to what many expect will be Betelgeuse's fate. The immense power and aftermath of SN 2023X provided an enticing glimpse into the processes that massive stars undergo as they approach the end of their lifespans. For many, SN 2023X served as a preview of what might occur when Betelgeuse meets its fiery fate. The greater cosmic significance. Whether it is a nearby star like Betelgeuse or a distant supernova like SN 2023X, these cosmic phenomena remind us of the dynamic and evolving nature of the universe. Beyond the realm of astronomy, the explosion of Betelgeuse would have significant cultural consequences. The star, admired for centuries, would vanish, prompting reflections on impermanence, cosmic time, and our place in the universe. A supernova of such magnitude could also ignite a renewed interest in astronomy, much like the surge of curiosity that emerged during the Renaissance when celestial observations began altering our perception of the universe. Scientific and technological implications. From a practical standpoint, a supernova's effects could extend to technology. Increased radiation levels from such an explosion could pose challenges for satellite communications and navigation systems, necessitating advancements in shielding and protective technologies. As we become increasingly dependent on technology, understanding and adapting to cosmic events becomes crucial for mitigating their impact on daily life. A philosophical perspective. The fleeting nature of a supernova serves as a reminder that even monumental celestial bodies are impermanent. This realization may spark philosophical debates about existence and the passage of time. The universe operates on timescales far beyond human lifespans, yet we find meaning in our brief moments under the heavens. As we contemplate Betelgeuse's potential supernova, it is essential to understand the broader implications of such an event, not just for science but for our cosmic perspective as a whole.